Hello. Hello, good evening all.
Yeah, good evening, ma'am.
Yeah. So today we will see, like, if you have any doubts from any week from week 1 to 5, you can ask me. And also we will see 2-3 visualization from week 5. So should I start first with visualization part?
Yes, ma'am.
Okay. Yeah.
मैम रिजल्ट कब आएगा मैम व्हेन विल रिजल्ट विल बी आउट
Result will be out in maybe in 1 or 2 days.
ओके मैम थैंक यू
Yeah. Okay, so many of you had doubt in the marginal of the unit square that has been discussed in week 5, right? So let's see. So we have a square here that you can see. Now, if I want to, let's say, what is mean by slicing, right? So if I want to slice this cube parallel to, let's say, horizontally or either vertically. So let's say first I'm slicing it vertically. So here your this blue axis, this represents your z axis, okay, and this red axis denote your x axis, and this green axis here denotes your y axis. Okay, so you have a square here, cube here. Now please mute. Is there? Okay, so let's say first I want to slice this cube vertically. So what do you mean by slicing it vertically? So we'll have to fix a point on x-axis, right? So let's say I'm fixing some x equals b here. So some x equals b. So b is varying from here -5 to 5. So let's see this. So it can let's change. Let's make it 2. Let's make it 2 and -1. Okay. So once I stop this, so in this case, it is slicing your cube at x equals 0.77. So this is how it appears. So if I have to find, let's say, fx, right? So what do we do in case of fx? To find the marginal distribution of x, we integrate with respect to y. And in that case, we fixed our x. So here we are fixing our x at 0.77, let's say. So this is the square that you will get here. In the lecture, you must have seen, like if we find the fx, then it looks something like, okay. So it will go from 0 and it will go till 1, right? If it is a unit square. So in this case, it is somewhere above 3. So your fx, your x is fixed. So on the z axis, this point is fx, where your x is what? In this case, it is 0.77. So f 0.77 comma y, and your the horizontal axis, it will be y. Y will vary from in this case, it is somewhere from minus 3.2 to 0. So similarly, we can also slice it with respect to, we can also slice it vertically parallel to the x-axis. So if we do that, so let's say this is the slicing. So in this case, the screen axis is your y-axis, right? So if I want to find fy, so in that case, we slice, we do the slicing, like we fixed our y and we integrate with respect to x. So as this slicing, as this y will move, you will have to just integrate, you will have to integrate your fxy with respect to y, and you are fixing your y here, correct? So this is what
Green is y-axis.
green is the y-axis.
Okay.
Yeah.
Okay.
Yeah. So red part is x-axis, green is the y-axis, and blue line is a z-axis. So this is what we mean by slicing. Is the slicing part clear?
Yes, ma'am.
Okay.
So we slice for whatever variable we don't have to integrate.
Yeah, right. So if we are integrating, if we have to find the marginal of y, then we slice like the with respect to y, like I fix some y and then slice it, slice the this region, this surface. So if you slice it, you will get a square kind of thing, right?
Okay.
And that area, the area of the slice portion is
Mhm.
the measure of the probability divided by that.
Yeah.
How it is related? This slicing is related to the probability.
So this slicing, this okay, let's go back to the first okay. So this slicing, so if I slice it with respect to, like if I fix some x and slice it, then in that case, you see a square kind of thing, right? So the screen surface here, so from there till 0, and then it will go to fxy, and then again it will go till let's say 3, and then again it will go to the y-axis. So that gives you the like that is the reason that we're talking about here. Like if you integrate.
In case of uniform,
Sorry.
in case of uniform only, or all the cases?
In all the cases.
In all the cases. If the
Yeah, it's
ununiform region is also there, then it will go along to that function.
yeah. Let's see that also. Okay. Please mute. Okay. So here you have a hemisphere, right? In this case. So right now, if I want to slice, so again, in this case, the red is your x-axis, the green is your y-axis, and blue line is the z-axis, right? Okay. Now, p equals okay. Now, if I want to slice, like if I want to fix some x, right, and if I want to fix some x and slice it, like slice this surface, right? So let's see this. So p equal x equals p here. So this is the this is the plane, like this plane is intersecting the surface. Okay. So if it, let's move this. So as it slides, so you can see this, region is changing, like the point of intersection, the intersection of the curve and the plane, it's changing, right? So if I have to, so now let's see the intersection of this. Okay. So this is the path that it takes. Huh? So if I have to integrate with respect
This is the y part.
Yeah. So
and we are integrating along y.
we are integrating
along the support of y.
Yeah.
So this is the support. This is the support of y. This curve.
Support is this whole like -1 to 1, the circle, right? This is the support. Now this is the plane. Like if I'm fixing my x, I will have to integrate with respect to y. Correct. So let's see here. I am fixing my x at 0.57. Right. So I'm fixing my x at 0.57. And if I have to integrate with respect to y, so how is the y varying? So y is varying from, let's see here. So y is varying from 0 to this surface, right? This curve that you are seeing here, that intersection curve, this black line, right? So it will go from 0 to this curve.
0 on the y-axis, na ma'am?
0 on the y-axis, right? So y is varying from 0 to...
It will go along the green line, na?
There is no green here.
Green axis. Green axis is the y-axis.
Okay.
So it will go along that or along the section. Another axis will be there for integration of the slice. What I mean to say, one axis is the red axis, green axis, and blue axis. That is defining the function. When we integrate, then the y, the support on which we are integrating, will have another axis that will be along the section. Or it is the same axis. This is the confusion. My confusion is that.
Okay. So if you have a surface, let's say you have, okay, before this, let's see another example. Okay, let's see this example first.
Yeah.
Okay. So suppose my reason of integration, like the reason is x plus y less than equal to 2. Okay. So let's say that. So for that, we'll have to draw x plus y equal to 2 line, correct?
Yeah.
So we have drawn this x plus y equal to 2 line. Now I am just indicating the endpoints. So the endpoints will be what? It is going to be 0, 0, 0, 2, and 2, 0, correct? So I have 3 points here. So let's denote all these 3 points on the curve. So we have the 3 points here, 0, 0, 0, 2, 0, and 0, 2. Now we have like ABC. So I'm just making this polygon here. So this is your reason, that is x plus y less than equal to 2 and x greater than 0, y greater than 0, right? This is the reason that you see. Now if I draw a, let's see. So if I have to, let's see here. So if I have to integrate, let's say, okay. So if I have to integrate with respect to x, okay, in this case, so if you have to integrate with if you have to find fx of x, so you will fix your x, correct, and you will integrate from 0 to like you will integrate with respect to y. So
Yeah,
in
yeah.
this case, y is varying from, there is some background noise. Okay, so y is varying from 0 to this curve, right? This plane here, x plus y equal to 2. This plane is x plus y equal to 2. So your y is varying from 0 to x plus y equal to 2. In this case, so y is varying from 0 to 2 minus x.
2 minus x, right?
2 minus x.
Right,
So,
right.
but this is the 2D reason that we are saying. This is not the 3D, right? So if we have to look at the 3D part, here, yeah. So okay, so this is your 3 dimension. Now I am plotting this x plus y equals to 2, right? So this is the plane that is x plus y equals to 2. Okay, so look at the point of intersection here. It is 0, 0, 2, 0 and 0, 2. So if I have to integrate with respect to x, so if I have to find fx of x, I will fix my x and integrate with respect to y. So again, what we will do, whatever the surface is, so this surface is x plus y minus 2 equals 0. So the limit of y will go from where? So if I plot p equals x, p such that x equals b, then look at this surface. So this is your, this blue plane is x plus y equals to 2, and here you're fixing your x, right? And you'll have to integrate with respect to y. So you will vary your y from where? You will vary your y from 0 to this plane, right? And this plane is x plus y minus 2 equals 0. It means y will vary from 0 to 2 minus x. Right? So
Which line is x plus y is equal to 2?
This plane, the blue plane that you're seeing here, this thing.
Okay.
So this is your x plus y equals 2 plane.
Yeah. X plus y.
So there we had seen the 2D figure. This is a 3D figure. So
Yeah.
for simplicity, we always consider the 2D part because it's easier for calculation, right?
Yeah.
So you see, like if I, so this triangle, this light blue color, this is generally what we draw as x plus y equals 2, right? This blue, light blue region.
Yeah, light blue region with, yeah.
This line, we say this is x plus y equals to 2, but this is actually a plane, right, in 3D.
Yes.
Now, if I have to, again, integration part, it's the same. So there are many things like
So
this.
Nikita, what would be the significance of this? What would be the significance of this particular thing? Now there is a density also that comes into the picture, and that will be on the z-axis, right?
Yeah, right.
So when we are doing this marginal calculation, and this density would be increasing from 0 to and going up to the line. So it would be a kind of an inclined plane that has formed, if we relate with what was given in the example. So what is the significance if I want to understand from the density function and doing the integration?
Density function and doing the integration. So if you do the integration over the whole support, you will always get
So
the
for
area will
example,
always be equal to 1.
when we slice at some area, when
Yeah.
we slice at some fixed x,
Yeah, right.
right? So then what are we exactly calculating after we have done the slicing? We have fixed the x and we have done the integration over y from 0 to whatever, what are we exactly calculating with this, looking at the figure?
So this figure, okay, so I have done this because so that you can see how this x and how do you take the limits for the variable when you integrate, right? So I think you had only asked it out on this course. So if you slice it,
Right.
how did we get the square that has been done in the lecture? So this is the
Correct,
slicing
right.
part. Huh? Now, okay, if it is a discrete case, and if I have to find the, let's say, the marginal PMF of the random variable x, then what we do is we fix some x and we sum it over all the y.
Vice, right.
So in this case
Yeah.
also, if I, let's say, if I'm fixing Rx, so in this case, if I'm fixing Rx here at this one somewhere.
This view is
So
fine.
if I'm fixing,
Yeah, this view is fine.
so this whole thing from 0 to this y equals whatever, this is 3, let's say.
0 to
So from
3, yeah.
0 to 3 somewhere, we are integrating it. And we are getting this area, this, what is the area of this square that we're getting? So
Of the
that
cube,
is,
0, that would be the cube, right? That
that
has
would
formed the red area.
not the cube. It's just a square, right? Let's say this. If I'm
Would we not
fixing one,
consider the z?
if I'm just fixing my x,
X, okay. Yeah, fine.
if I'm
The
just
rectangle
fixing my
that will
x,
form, yeah.
so you have a square here.
Okay.
So that area, that is going to be a like fi, because you will be integrating from over the y. So this is nothing but it is uniform, right? Uniform distribution.
So this, when we slice that and integrate with respect to y, we'll be getting fx, right?
Sorry.
In this case.
Yeah, in
So
this case, we'll get fx.
And fx is
And
an area, not an volume, right?
so fx is, so what we'll get fx as, it is in this case, so this square here. So how do you draw the graph of the uniform distribution between two intervals?
That is an area.
Yeah, so area under this. So area of this, the square that you're getting.
Yeah. Means
Square
marginal,
that will be
marginal,
marginal, right?
marginal is fx and fx is area, not volume.
No, that is not volume.
Okay.
Like if you're fixing a x.
Okay, so can I say that, in the case of this uniform distribution, whatever this figure is there, fx would be the projection of the figure on the xy plane.
Yes. So if you it's about the unit square, right? You told about the unit square.
Unit square is easier because if it is uniform, then just we get the area of interest divided by
Not
the
the
whole.
XY plane. I think projection not on the XY plane, but projection on the YZ plane. That is what I understood.
It is projection on
Right?
no, it is projection on
YZ
the
plane.
XY
Because you
plane.
are saying the area that is, if you are slicing at X, red axis is the, red line is the X axis, right? If we
Red
are
line is the
slicing at,
x-axis. Yeah.
yeah, if we are slicing at on the red axis, then in the XY plane, we are not getting any square. We are just getting the square on the YZ plane.
We are getting the square on the y side. Okay, green is the
YZ
y
plane.
and z is the, yeah, in this
Blue.
case it is YZ plane.
Correct. So
Yeah.
we are getting that square only on that YZ plane and not on the XY plane.
Yeah, we are getting this on the YZ plane, right?
Right?
Yeah.
Here, what I have to add is, The square, okay, so this square is, I believe, it's just for a particular value of x, when we are fixing a particular value of x. So if we vary, along the limits of x, then the square, right now we only have a line on the xy plane, which is the projection of the slice, or the, the plane which is running perpendicular to the x-axis. So
Yeah.
if we vary the slice, some say the over across the limits of x, then we would get some kind of a projection, right, along the on the xy plane.
Sorry, can you repeat the last part?
If we vary this slice, from along the limits of x, since this slice is perpendicular to the x-axis, so
Yeah.
we should logically get a projection onto the xy plane, right? Since this slice currently, if we take just the point where the slice is currently, it is nothing but a line on the xy plane. So if we vary the slice along the whole on the limits of x, then we should be getting some kind of a projection, or some
On
kind
the
of
xy plane. XY plane,
But then
right?
Nikita, you said the square on the XY plane, how that square is getting formed is my doubt. Slicing it on the x-axis, now with the same position, I do not see a square after you have sliced it. I do not see a square on the XY plane. I see a rectangle. Where is the square? This is a rectangle that I see on the XY plane. Is that what you are referring? Or are you referring the square on the YZ plane?
I am referring to the square on the YZ plane. This part is for what we have seen in the lecture.
Yeah.
The slicing
Okay,
part.
This slicing part.
sorry to interrupt. May I know your name? You were just mentioning something. The square on the YZ plane.
Yeah, this is Apul.
Yeah, Atul. So see, what I was mentioning was my line of thinking is if I just slice this square, or cube or whatever, if I slice
Nikita,
this,
can you give this names are there, right? Yeah, so we can see the
Okay.
point. What I am referring to, can you give some letters to the sliced portion also, which is touching
Okay,
the square? Yeah,
let's see.
Nomenclature is difficult to put on that.
Let's see.
Can you put the name by the coordinates, XYZ coordinates?
Yeah, that's what I'm
0,
doing.
0, 0, A is equal to 1.5 and B is equal to,
Just hold on.
please.
Can you mute? Okay.
or should we just try? I mean, the point
Yeah.
which is slicing the square, the bottom portion,
Sorry.
which is between C and D.
Which is between C and D. Okay.
Let's call it as alpha.
Okay.
The point which is on the square between G and H.
G and H. Okay. The red part or?
Yeah, I mean, yeah, the red
Okay.
part
Hmm.
as beta. So
Okay.
basically, I mean, alpha, beta, gamma, and delta. If we give the 4 letters to the portion which is slicing the square, right? It will be
Hmm.
easier for understand to which which figure are you referring? Are you referring to alpha, beta, gamma, delta, or are you referring to C alpha delta B as the area after slicing? Did you get me?
C alpha delta B. C alpha delta B.
Alpha is the portion, yeah, with this position, alpha is the portion which is between G and H. Between G and
Okay.
H, alpha. Don't change the
Okay.
position.
Okay.
Between G and H, not this line, above, the top line.
This part.
G and H.
This part.
Yes. So this is what I refer to beta.
This
The
is your beta.
intersection, Nikhil.
Okay.
The point,
This
just the
point.
point.
This
Yeah,
point.
this
This
is the point
point.
which I'm referring to beta. Yeah.
Okay. Yeah.
Yes. The point which is under it, I'm referring to as alpha, which
Okay.
is between C and D. Correct. This is alpha.
Okay. Huh.
Okay. The
Huh.
point opposite to this,
Yeah. The point opposite to this. Okay. This one.
there are,
Uh,
yes, this is what I'm referring to delta.
okay.
Delta.
Oh.
And above this, I'm referring to gamma.
Okay. Beta
Just
delta.
above this, I'm referring to gamma.
Okay. So okay. So when
Right now, you might want to refer what figure are you referring? Are you referring to alpha, beta, gamma, delta, or are you referring to the area which is formed by C, B, delta, and alpha after slicing?
okay. So after slicing, I was referring to this alpha, beta, delta, and gamma.
Gamma. Okay, fine.
Yeah. So this square I was talking about. So if you look at the figure, it will go from the y-axis and then go till fx not y, some y, and then again it will go down and it will move from 4 to infinity. So this square I was talking about.
Fine. Got it.
Okay. So
I still miss the point. What are we struggling here?
sorry. Yeah.
What are we all struggling here to see that the whole 3D in a different perspective? You still get confused on XY plane and YZ plane.
Yeah, because like if you like many people have faced difficulty in taking the integration limit when finding
Yeah.
fx
So
and fy.
what you're trying is you're just taking a section as a square and
Yeah.
integrating on the third axis to get the volume of the cube, right?
In previous example, yes.
Is that the attempt you are making? You're integrating the cross section across the other third dimension, is it?
Integrating, sorry.
Integrating the square cross section
Huh.
across the third axis to get the volume of the cube, 3D object. Is that what we are trying?
We were just trying to see how the slicing, like if you slice, what do you mean by slicing a surface? So
Okay.
what is the curve that you get? And if you take the, like if you have a surface and if you have to take the integration, why do we take, like you have a support, let's say from x varying from 0 to 1 and y varying from let's say 0 to 2. So if you have a surface, like people generally take, if you have to integrate with respect to x, like if you have to find fx, instead of taking the surface, people generally take whatever the limit is, the support is given in the question. So why do we have to, when we're integrating, why should we take the surface as one of the limit? Like, why do we take that limit?
Surface is the limit.
Like in this case, like this line here, this line passing from 2 to, this is x plus y equals to 2, right? And our x is 0 to 2 and y is 0, like x is greater than 0, y is greater than 0, and this is the support that is given to us.
Right.
Now if somebody, if it is asked like find fx, right? So it is the general tendency that if you have to find fx, student, like many students, like generally they do, like they integrate with respect to y and they take the limit from 0 to 2. So there it is a mistake, right? So why should we take like just to show why it is not the upper limit in this case, like why is it not 2, and it should move across the surface, across this plane, right? So this plane is your so why should vary from 0 to 2 minus x?
Why should vary from 2 minus x? Okay.
Yeah.
All right. So you were trying to show that in the 3D, is it?
Yeah.
Right.
So, okay, so what we can do is like we can create few applets, let's say 2-3 applets, and then just for your visualization, like for your practice, you can just go through it and like do some experiments there.
Great.
After integration, it gives ma'am volume gives or area. It gives volume, na ma'am.
After you integrate this whole surface, yeah, it gives the volume. Whatever volume is occupied.
One thing I would like to share, maybe whether my concept is wrong or right, you can justify.
Yeah,
because we don't have probability is 0 at a particular point in the
in continuous.
That's why we integrate the slice, right? And that slice is dx. If you are integrating at that slice, the thickness of the ds is giving the volume of that slice. Is it so or not? And we are integrating the small slices over all the area of the xz plane. Is it so or not? Then it will, the whole volume will be integrated.
Then the whole volume, then this whole thing will give you 1. Like
whole thing will be give. The whole thing will give 1 because the probability. The whole probability will give 1 because the whole volume is the triangle. The triangular part is giving a volume, that in a volume. And
this is not the surface. This is just a plane.
This is the plane in 3D concept. The whole volume is divided. The area of the triangular part and the slices we integrate over the x-axis. Then this gives the whole volume. The whole volume it will give in the 3D, and divided by the whole volume it will be 1. That's why the concept verifies. Is it so or not? The whole slice, the slice we are taking in dx.
Okay. Who is?
Ma'am, is it volume or surface area? I mean, I'm confused with that. Like the total fx5 when we integrate over x and y, is it the surface area or the volume we are calculating when we integrate over x and y?
Can I say something? If you can just go back to that x plus y equal to 2. I mean, I would like to see any of mine.
Yeah, just hold on. Yeah.
So I would like to start with this 2D plane. So consider this is some function fx. I mean, the line running, just whatever line it is some function f of x. So we have to find the probability of this. The cumulative density, then we typically integrate with respect to some limits of x. Since we don't have y or anything here, whatever we integrate, it actually gives us the probability for x. When
that gives you the probability for x. Yeah.
Now, if we go to it can just go to the cube on the 3D plane.
Yeah. Right. Wait.
Okay.
Yeah, this one.
Good. Just uniform distribution. Okay, yeah, this is also fine. This is also fine. This is x plus y minus 2 equal to 0. Okay. So
Yeah.
if we actually consider, the case when we are saying that, we actually slice that, with a plane path which is perpendicular to the x-axis. And so in that case, we are considering the limits for y. Say at a particular slice, we are considering the limits for y.
Yeah.
And for each point in the support of x, we are actually considering the limits of y. So
we are
basically,
considering the limit of y. Yeah.
Let y from the picture. Find the marginal distribution of x.
Marginal distribution of x, right?
So whatever is the final result would be the distribution of x as plotted on the xz plane, right? Is my understanding
distribution correct? Of x plotted on the xz plane.
No, my volume should be there. The whole result will be volume, na, ma'am, after integration.
Oh, that is the total. In this case, there is no volume, no? I mean.
Yeah, in the slice, in the case of slice, it is not volume, it is area. But after integration, we get the volume.
I think it is surface, not volume. Like area.
No, ma'am, what I mean to say, this is the probability bounded by the three surfaces. One is xy is equal to 2, second is x-axis, the third is z-axis. Am I right? A y-axis and z-axis. Is it so or not? It is the bounded by the area. xy is equal to 2. 1.
Xy
second,
equals 2.
Yeah. Second is the x is equal to 0 and y is equal to 0. Is it so or not?
Okay, so all right. So if I'm taking x equals 0 here and y equals 0 here, so you will let's see.
That is the volume. We are concerned about that because this is the area bounded by x is equal to 0, y is equal to 0, and x plus y is equal to 2. Is it so or I am wrong in my concept?
I'm not able to understand.
Suppose x is equal to 0. We are drawing in the 2D x plus y is equal to 2, a line. Okay. And this is the actual, this is what you are showing, man, in the blue and light blue. It is x plus y is equal to 2. Is equal to 2 is the plane, right? But this plane is bounding the between two other areas also, that is y is equal to 0 and z is equal to 0. No, x is equal to 0.
X equals 0 and
y is equal to 0.
How?
Because these three planes will bound in volume. Is it correct or not?
No. How is there is a volume?
Three surfaces are there, ma'am. X is equal to 0 and y is equal to 0. And third is x plus y is equal to 2. There are three planes. And three planes can make a volume. And whatever you are showing in the whole
volume, I mean, they can cover a surface.
Or I am wrong. If it is not, then we are calculating the same thing.
No, you may be wrong because unless these three surfaces are converging to a point or a line, you don't really take a volume. It does not appear to be like that.
See, if I draw x equals 0 here, so this line on x equals 0 here, right? So this plane here y equals 0 and this plane here x plus y equals 2. So can you see
volume is not bounded by that.
It is not bounded, right? There is no closed surface here.
Yeah. This is not closer. No closed volume. There is no closed volume. But in 2D, what we are doing is actually bounded by the three lines. X plus y is equal to 2, x is equal to 0, and y is equal to 0. This is the confusion here. that 2, 2, line is x plus y is equal to 2, x is equal to 0 and y is equal to 0. These are the three planes, na ma'am? What I understand.
Yeah, these are the three planes, and
Third
if you
plane
have,
is x plus y is equal to 2.
yeah, right.
Then if this is the volume, the bounded area is the volume, whatever you
This
are
is
showing.
no, this is not the
Okay.
volume.
Okay. Yeah, this is not the volume, right? This is the infinite surface, right? Infinite area, and we are taking the slice of that, and that slice creates the volume, right? Yeah. This slice is creating volume bounded by between that what I am talking about, the three planes. This slice is making the volume part. When we integrate over that,
okay, just hold on.
is it so, no, ma'am?
Just hold on.
Okay,
Just
okay, okay. In that context.
And just let me see. Lecture 5.4. What is there in lecture 5.4?
Marginal densities.
Okay.
The example that you have demonstrated, that is a part of 5.4
Okay, all right.
of the cube. Yeah.
Ma'am, can you all the three planes and then move along the slice, and it will show something in 3D. Is it possible?
Sorry, can you repeat?
All the three planes already you have drawn in the 3D,
Mm.
and this slice part also you can move along that. And what is shows? It shows volume or not? Can
Like
we?
if it moves throughout the surface, then it gives you the total volume covered by that surface.
Okay, that three surfaces.
But apart from that, if it is just one slice, it will give you this area.
Yeah, that will give
surface
area.
area.
Yeah, correct.
Okay. Okay, so for week 7, you will come across, okay, in graded assignment, you don't have the FZ values given to you. So you can also use the normal calculator, or you can use this applet for normal distribution, from where you can calculate the FZ values. So this you can use for solving the graded assignment if you want. This will put on the portal. Okay. Okay, if you have doubts from week 1 to 5, you can ask your doubts.
I have one doubt, ma'am. In the normal distribution, when we transform x y is equal to xz plus x, and how to convert this into normal?
Yes, ma'am. Same doubt I have.
Because
Sorry, y equals?
Y is equal to xz plus x, and we have to calculate some xz plus
xz plus x.
Yeah.
Where is this?
The sum of
Graded
uniform
assignment,
and normal. That is
question
what he
number 2.
means.
Yeah. Question
sorry,
number
Sum of uniform and normal random variable. How do
Yeah.
we conclude that it is normal?
Yeah, whether we will change sigma or mu both. This is the confusion. After when we transform, then whether we should change and how to change it.
This is from week 5,
Week
right?
6, I think. Week 5.
Week 5.
Just let me see which is it. Week 5 is.
Okay, so it's from the problem that sir has given.
Yeah, if a problem was there, I could not solve that. That's why I asked.
Somebody has put
Because
the
in the lecture it was only for the transformation of the x is y is equal to xz.
yeah, right. Yes. Okay, can you check the link from this course? Okay, is it the question that you were asking?
Yeah, ma'am.
X5 plus xz plus x. So
X,
it is in the graded assignment?
yeah, graded assignment.
Okay, wait.
Can I so this is
Okay,
question number.
wait. So did you check the graded assignment solution?
Right now, I did not check, but confusion was there. Maybe solution. They are giving the solution and how to convert in other cases also. A basic fundamental thing I'm not able to understand.
Hello, ma'am.
Yeah.
You can check the hello.
Yeah, right. Hello.
Hello. Yeah, ma'am. Can you please check the discourse that I just posted? I have some confusion on the same question.
Yeah, I was checking your post only.
I was trying to solve in a different way, but I'm not been able to like think like how to approach in that way.
Okay, so
I have got the solution, but still like I was trying to solve in different way.
okay, let me share my screen first. This question.
Yeah, this question. This is the question number 2.
So, okay. So your random variable y is given by xz plus x, where x is uniform in 1 to 3 and z is normal. And it is given that x and z are independent. So you have to find the value of x given y equals 2 of 2. So what is if x given y equals 2? It is going to be probability that x equals 2 comma y equals 2 divided by probability that y equals 2. But we don't know whether what is the distribution of y here, right? So how do you find the distribution of y? So x is given to be uniform 1 to 3 and z is normal, z is given to be normal, correct? So if you like if you fix your x, then what is the distribution of y going to be? So okay, so if I'm fixing my x to be 1, right? So if I'm fixing my x to be 1, then y is going to be z plus 1. If I'm fixing my x as 2, then the distribution of y given x is going to be 2z plus 2. If I'm fixing my x as 3, then my distribution of y given x, y is going to be 3z plus 3, right? So if we know that this like z is normal in 1 comma 4, so can we find the distribution of z plus 1? So how will you find the distribution of z plus 1?
It will be shifted by like 1.
Yeah, so only the mean will get shifted by 1 unit. The variance will remain the same. So have you solved the activity problems from week 5?
We could not, ma'am. We could not.
Okay,
solve
okay,
that
okay. Even if you, okay. So if I have to, we know that Z is normal in 1, 4.
Yeah.
Right? Now, if I have to find the, so Z plus 1 is what? You are just shifting it by 1 unit.
One unit.
So if you have to, so this is again going to be normal distribution.
The mu
You
will
can,
be
how
mu
will
plus
you,
1.
yeah. And how will you check this Z plus 1 is normal? If you, let's say if you cannot visualize and if you want to check manually. So you have studied function of random variable. You know
Yeah.
how to use the monotone differentiable function theorem and to find the distribution.
Yes, ma'am.
Yeah, monotonic. If it
Right?
is monotonic, then
You have studied that. So
yeah.
from there also you can check. Now, if I have to, so okay, let's say I know that the distribution of Z plus 1 is normal distribution. Now, how will you find the expectation of Z plus 1? So expectation of Z plus 1 is going to be expectation of Z plus 1. What is the expectation of Z? It is given to be 1. So 1 plus 1, 2. And what is the variance of Z plus 1? It is going to be variance of Z. So variance of Z is again 4. So this distribution of Z plus 1 is going to be normal 2, 4. Similarly, what is the expectation of 2Z plus 2? How will you find the expectation of 2Z
Variance
plus
is same because the factor of Z is 1. Because
factor of Z is 1. Yeah.
Because that varies according to the square of that, right?
Square of the coefficient of
Okay.
random.
Yeah. According to that, it is okay.
So if you have to find the variance of 2Z plus 2, it is going
Then
to
it
be
is
4 times
yeah, it is okay.
the variance of Z. Similarly, you can find the distribution of Y given X equals 3. Now you have the distribution for all those Y given X equals 1, Y given X equals 2, and Y given X equals 3.
No, here my mu is 4.
Yeah, mu is 4 because expectation of 2Z plus 2 is what?
Yeah, 2 into
2 times expectation of Z plus 2.
2 times then
Plus 2.
First 2 times. Yeah, transformed.
Yeah. Now, what do we have to find? We have to find probability X given Y equals 2 of 2. So in the numerator part, it is going to be f of x comma x equals 2 comma y equals 2. And that we can also write it as f of y given x equals 2 into fx of 2. Right? And fy of 2, for fy of 2, we can write like, what is meant by fy of 2? So fy given x equals 2 into probability that x equals 2. Then f y given x equals 1 of 2 into probability that x equals 1. Like the Bayes theorem, simple.
Integrate.
It's like a Bayes theorem, right?
Summation of the product of the marginal and conditional.
Yeah. So we already know the distribution of x. We already know the distribution of y given x. Then we can just substitute and find the values. Right?
Then fx2 is the whole. Fx2 is the denominator part is fx2, na ma'am.
Denominator part is fy of 2. Fy of 2. How will you write f x given y equals 2 of 2? Probability x equals 2, y equals 2 divided by probability y equals 2.
Okay, probability of x given y is equal to 2 of 2. Yeah.
Right? Okay. So, okay, what is wrong here? If y given x equals 2, probability x equals 2. Okay, this is fine. X
Ma'am, I was
equals
trying
2.
to find the z equal to. I was trying to find trying to write the.
Yeah, you were doing
X
it.
and Y.
You were doing it right, but you didn't complete, no?
I didn't complete, but like the answer was wrong, and whatever I was getting, I was trying to write z in terms of x and y, and then I was trying to calculate.
Okay, if you write
like f of y.
Okay, this is fy equals 2. given x equals 2, okay, divided by probability y equals 2. So x equals 2, this is z, is it?
Yes, yes, ma'am. Yeah.
If z equals 0.
If you put the
Why did
value
you
of
write?
y, if you put
Why
the
did you
value of,
write z equals 0?
yes, ma'am. If you put the value of y and x in like that equation, and from there we get z equal to 0. That thing I'm
Okay.
confused.
So okay. So this is what? This is the distribution of given x equals 2.
Yes, ma'am.
It is given that x equals 2. What should be the distribution of y equals 2? Like what should be the distribution of
Y
f
equal to 2, yeah.
at 2? So you cannot write the distribution of y as distribution of z.
Yes, ma'am. That thing I'm confused. Like why?
You cannot write the distribution of y as distribution of z. This is wrong. What you have written here.
Yes, ma'am. There's no confusion. I mean, why we cannot do that?
Because see, what is this? This is probability that y equals 2 given x equals 2. Huh? So
Yes.
what is mean by that? Given your x, you have to find the distribution of y.
Yeah.
So that is not equivalent to putting putting x and y and writing z, writing the distribution of z. In the numerator part above, it is your distribution of y. Given x, you have to find the distribution of y at 2. That is not equivalent to x equals, like putting x equals 2 and y equals 2 in your fxy.
Is it because, ma'am, like x can, like if we take x equal to 1 and y equal to 1, then also z equal to 0. If we take x equal to 3, y equal to 3, then also z equal to 0.
Yeah.
Is it because of that?
No, it is the distribution of y we are talking about, and you have written the distribution of z.
Okay, like if like
It is, these are
eliminating
not
the
same.
probability, then we can write, right?
These are not same. In the previous step, it is what you have written is, like if you know what x is, like y is xz plus x. If you know what x is, what should be the distribution of y? This is what it is mean.
Ma'am, like in case of probability, we can write, right? Like if it had been like
This is
P of
probability. This is probability only.
density.
So you cannot substitute the values of x and y and say it is equivalent to z equals this.
Okay.
Okay. Any other question? Any doubts from week 5?
I don't have any doubts specifically from week 5, but how do you find the distribution of a probability from its graph?
How do you find the distribution of
Yeah, the probability distribution from graph.
probability distribution from graph?
Yeah. Let's say some distribution is graphically represented. How will you know it is of this probability distribution from just its diagram? Like we can.
Okay,
Can we
so
get a hint?
So for normal distribution, okay, so somebody has asked, okay, Mrityunjay, I will come back to your question. Okay, so in case of normal distribution, you know, it forms a bell-shaped curve.
Yes, ma'am.
So that is easy to identify. Then in case of exponential, you know, how does the graph look like?
But what if a graph has a bit left or right skewed distribution? Like it has a bell shape, but what if it is left or right skewed? Does that mean it is still a normal distribution?
No, in that case, it cannot be normal distribution, no?
Yeah, that's what I'm asking.
Yeah, if I am talking about a normal distribution, so if I'm talking about a normal distribution, it is always going to be a bell-shaped curve and it is going to be symmetric to your mean. So in this case, if your mean is 0, then you see it is symmetric, right? It is symmetric over the mean.
Yeah. So, my question is, like, we can somewhat guess some stuff, but what if there are a few graphs that are like not what we think they look like? For example, I just gave a left skewed graph or a right skewed graph, a bell-shaped left skewed graph or a bell-shaped right skewed graph. What can we infer from the graph regarding its distribution?
What can we infer from the graph regarding the distribution?
Yeah.
So, so if it is left skewed and right skewed, definitely it is not going to be normal distribution.
Yeah.
Right. So we can infer, like if you have some data and like your graph is, it's a left skewed or right skewed, you can say something for the data. But from there, identifying the distribution is like correctly identifying it's not so easy. I mean,
like, is there any method to find out what distribution it might be? Like, is there any?
So have you gone through week 7 content?
No, I haven't. I'm still
no. So if you go back to week 7, so in the last lecture, I will show you. So you will see many such graph for the gamma distribution, for beta distribution, and all that.
While Googling, I did see quite new names in the internet, but I didn't have an idea as to what they are.
Yeah, so so once you go back to that lecture, so you will see many such, one you will see beta distribution and gamma distribution that will be used very frequently in the later weeks also. So there are many like cases like when you
which distribution, gamma distribution and
gamma distribution and beta distribution.
Gamma and beta will be here.
Yeah, it will be used very frequently. So if you can identify, if you see a graph and if you know how the graph of gamma or beta looks like, then it's easier to get some information from the graph. Like if you know the distribution, you can easily find the expectation, the variance, and all that.
So will we like learn how any method or something to find the distribution of a probability just from its graph? Like, will we have any method to do that? Because basically I have this doubt because we were told to do this week 4 assignment, right? We were asked to collect data, and then we were told to make a graph and then understand what kind of a distribution it can be. What I did was I tried to make it look like a binomial distribution. Like I literally manipulated some data so that it looks like a binomial distribution.
Yes, ma'am.
But,
Myself also stuck in that. Manish, what is it? I was not able to find out the what distribution is of type.
Okay, I will just
So
share
I
my
didn't
screen.
know what kind of method I could use to find what kind of distribution it is. So is there any actual method that helps us find out what kind of a distribution it will be, so that it will be easier for us? Not because of doing any assignments now. I'm just curious to know, is there any actual method to find out stuff like that?
No, like there is not any particular method to find out the distribution, but for different distributions, you know, how does the graph look like? And if you have some data and let's say your histogram has the particular shape, then in that case, you can say you have this distribution that like your data fits this distribution. So like if you see this
based on
gamma,
that graph.
yeah, based on the graph, based on the, like if
Okay.
you get a histogram, and then after that, like from histogram you can see what is the shape of the distribution, right? So if you have some information like if you know how different graphs look like, then you can identify, I mean, like in case of the gamma distribution, it looks very similar to the exponential distribution. This gamma 1 1. So gamma 1 1 is actually nothing but your exponential distribution with parameter alpha equals 1. Then gamma 2 1 looks a little different. Gamma 3 1 looks different. So similarly for in this case you have beta distribution. So in beta distribution, it always lies between 0 to 1. So there is one catch here. So that you can take care of, like whenever you have something between 0 to 1 and your graph looks, it can have different shapes, but generally it belongs to the beta family. Okay, so you will have to like read about different distributions, and you can study.
I need to know a lot of distributions to actually understand this stuff.
Yeah, so there are many distributions actually. So maybe you can read something about different. I think gamma, beta occurs very frequently. Poisson, all that. So once you go to week 7, so in the last part, it is I think the last lecture. So you can get to know about his Cauchy distribution, beta distribution, gamma distribution. That also you can study, and then you can do your extra activity part. That will be helpful. Yes.
Yeah, okay. Madam, the point here is it's not what are all the distributions available, but how to fix a problem to a specific distribution. That's where it is.
No, what she's trying to say is, once you get to know a lot of distributions, like once you get to know the shape of a lot of distributions, you'll be able to associate what kind of a distribution it will be just from seeing the diagrams. What she's trying.
Yeah, then it will be easier for you to get some information.
So you got to really plot the data and try to match the profile to identify the distribution. Is it? That's what you're trying.
Yeah, like if you have a data, plot the histogram, and from histogram you try to see what is the shape, right? And if you look at the first graph here, so it is the normal distribution. Like the histogram resembles a proper bell-shaped curve you have, and I can say this is a normal distribution. So I can say my mean lies like the center is 0 and the variance is this and this. Similarly, if you look at the second graph, I can see that it is somewhere like it belongs to the exponential family. So I can get to know about what should be the mean and the variance. That information I can get. Right?
Okay.
So
that's the only way. There's no shortcut. By reading the problem, you cannot really reach over there.
Yeah, like if you know the problem, like you should know what different distribution means, like what is mean by binomial distribution, what is mean by and what is mean by Poisson, what is mean by exponential, and what all these distribution models. So once you get to know what all these distribution models and whatever information you have, whatever problem you have, and if you can figure it out, this problem should model this distribution. Okay. So the graph will also look somewhere similar to the distribution you're trying to fit.
Okay.
Yeah, even from the information you have, you can try to figure out what should be the distribution. What is this model?
Okay, you just got to match the profile and block the distribution. That's what you're trying.
Yeah. So you should know about, so the idea is you should know about different distributions, and you should know what, like if you have a situation given, like what does this model, like what distribution will it fit?
Got it. Thank you.
Yeah. Okay.
Also, I came across this thing called QQ plots when I was searching for this stuff.
QQ plot.
Yeah, I wasn't able to understand because I didn't have much time to look into it. But do you have any idea what a QQ plot is?
No, I will have to read a little about it.
Yeah. Okay. Thank you.
Okay. So
Ma'am, exponential and normal is only in the continuous, not in the discrete, no?
Yeah, they are for the normal, continuous.
Okay,
random variable. Yeah. So okay, somebody had asked quiz 1 result. Yeah, it will be released soon. Maybe in 1 or 2 days. Should be released. Couple of questions from probability having conditions on inequality. Okay, Mrityunjay, do you have any problems? I mean, that you want to discuss? You are there, Mrityunjay? Trouble solving week 5 graded assignment. Okay, so what what kind of problems you want to discuss? So in week 5 you have those continuous random variable like exponential, then integration part. So which part you're not comfortable with? Question number 4. Okay. Anybody else has problem in question number 4?
Week 5, ma'am.
Week 5, yeah.
Graded assignment.
Graded assignment, right?
Yes.
Okay. Is this a problem you're talking about? Okay. All right. So it says XY is uniform in D. So you have you have two random variables XY, and they are uniform in this region D. So what is this region D? This region is this circle that is x minus k whole square plus y minus k whole square less than equal to R. So it if you have studied maths, I think you should know this is the equation of a circle. So this is the equation of circle which is centered at k, and the radius is r. So we have drawn a circle, like the radius is r, and it is centered at k and k. So we have drawn a circle, and so the radius should be less than equal to r, so it should be inside, I mean the inside area. Okay.
Yeah.
My case value of k is 3. Okay, so if value of k is 3, it means your circle is centered at 3, 3. Now you have to calculate x probability x greater than equal to y. So what we will do is we will plot x equals y. So this is the line here is x equals y. Now what reason is which reason denote the event x greater than equal to y. So this reason on the right side, it gives the value, this reason is x greater than equal to y. So what, okay, so how will you find the probability of this reason? How do you find the probability of this
area.
reason?
Proportion of the area.
Yeah, you know that it splits like x equals y, split the circle in two equal parts, right? So
Half.
there, yeah, it is going to be direct half.
Directly we can say half, no ma'am?
Yeah. So area of this reason is what? So area of this reason is, it is the total, what is the total area? It is pi r square. Area of circle is pi r square, right?
Yeah, ma'am.
And this is just half. So you can directly say it is half. I think you must have missed to divide it by the total area.
Here, ma'am, K is given, the center is K, and we have taken here the center at 1, 1. Means whatever center is that, the probability will be same.
Yeah, the probability will be same. Only
Right,
if
na?
it is on the this positive x
Yeah, yeah, positive, yeah.
If it is on the first quadrant,
because in my question it was different.
it is always going to be half, because it is splitting the circle into two equal areas.
Yeah, got it.
So
I did it by first I calculated, then it took so much time. 15 was the center. So I calculated it took so much time, but at the first glance it is saying that it is half.
Yeah. Okay.
Ma'am, where area is concerned, here we are calculating. In some cases, suppose the area is not of the uniform shape, then at that time also we can calculate the area, and if area is area of interest is limited, divided by the whole area.
Divided by the whole area.
Suppose 2 or 3 areas are patches, some circle, some rectangle, and some triangle is there for the whole probability, and we are concerned about the area of the some part of that rectangle. Then some part divided by the all the summation of the 3 will give the probability, no ma'am?
Yes.
Is it so, no ma'am? Suppose.
Yeah. Okay. So is it clear who had asked the question? Mrityunjay, is it clear? Is it clear why is it half?
Yeah, I think he is agreed in the comments.
Okay. Yeah. Anything else?
No ma'am.
Okay. So you have all of you have started studying week 7.
I'm right now we are actually doing for the Python also. The exam is there.
Okay, so from week 7, you can the Chernoff bound part you can skip. Okay.
Which one?
The Chernoff bound. Like if you are interested, please go and study. But in case it is not very clear, so you can directly go to the CLT part and try to do it.
On which lecture, ma'am?
Week 7.
It is in week 7.
I don't think it's there in week 7.
Yeah.
Over the whole course.
The title is concentration phenomena. So there are a lot of like that there you will see like how the CLT is derived and all. So if you're not interested in derivation part, you can skip that portion. You can directly go to the theorem. That also can be done in week 7. Okay.
Ma'am, up to week 11 or 12, the whole this probability part and distribution part will go, or another topic will come?
So
away
from
this?
week 7 onwards, you are moving to the statistics part.
Okay, that is a statistics part. This is up to this is probability,
We
right?
were always looking, yeah, we were looking at the probability part. Now we're moving to the statistic part.
Okay, and this probability formulas will not be used there, or it will be used at the same time?
It will be used, of course, it will be
Anyways,
used.
yeah. Okay.
Okay, question number 7. Let me see. So, okay. This is our question number 7. Yeah, so what he has said, it is just you have to use the formula. So can you tell me where you're going wrong? That will be easier. I hope the steps is clear to you, but if you have doubt, like if you have gone somewhere wrong, then you can tell me.
Excuse me, ma'am.
Yeah.
Ma'am, the part you are talking about to skip, it belongs to which lecture?
Okay. The heading is the Chernoff, concentration phenomena.
Okay. And ma'am, lecture number?
I'm not very sure, but you can check.
Okay.
So the derivation of the CLT part, that you can skip basically. The Chernoff bound you can skip if you couldn't understand. But if you are interested in studying, please go ahead and read that. We haven't removed that portion because if you are interested, please go and read.
Okay, ma'am.
Okay.
Ma'am, one more thing.
It's lesson number 7.5.
Okay. Ma'am, in week 0 activity 6, ma'am, I'm not clear how to do this activity.
Activity 6 is okay. So the recent activity that has been given to you, you're
Yes,
talking
yes,
about that
ma'am.
one?
Yes, ma'am.
Okay, we'll see. Wait. Can you please?
As is coming.
Yeah. So okay. First we'll see this question. So I don't know what formula you're talking about. So we had to just find the conditional density. So it is you have to find probability that x greater than half given y equals 1. So you just have to use the formula for conditional probability. So what we can write this as? We can write probability x greater than half and y equals 1 divided by probability that y equals 1. So how do you find probability y equals 1? So this is just you have to find if the marginal density of y at 1, right? So if you find the marginal density of y at 1, so for that you will integrate your fxy with respect to x. And how is the limit of x varying? It is varying from 0 to 1. So you will integrate your fxy with respect to x, and the limit is varying from 0 to 1, and that will give you the marginal density of y at the point 1 if you substitute y equals 1 over here at fy of y. Now in the numerator part you have fxy x greater than half given y equals 1. So this is just the formula of fxy x greater than half and y equals 1. So we can directly substitute y equals 1 in your fxy. So what is the fxy given here? Fxy is given as 3xy 1 minus x. So we can substitute y equals half here. So we can substitute y equals half here. So if you substitute, you will get what you will get? You will get 3x by 2 1 minus x. Right?
Now, y is equal to half or y is equal to 1?
Oh, sorry, y equals 1. Sorry.
1, yes.
Y equals 1. So it is 3x times 1 minus x.
Yeah.
So that you will have to just integrate. Now y is fixed. Now y you have already substituted. So you just have to integrate over x. And how is this x varying? So you have to find the probability for x greater than 1/2. And x is lying between 0 to 1. So the range of the upper limit and the lower limit is going to be 1/2 and 1. So there is nothing more in this. Can you tell me what in what portion you have doubt? Okay, fine. Okay, let me see what is the extractivity this time. So in the previous week, it's the same as the previous week. It's just if you have done for the discrete distribution the previous week, this time you will have to try to fit some continuous distribution. That was the assignment.
Ma'am, if in the previous week I have done in the continuous distribution, then what I have to do?
You will have to do for some discrete distribution.
Okay, this time I have to do for some discrete.
Yeah.
Okay, ma'am.
That has been mentioned, right?
Yeah, and ma'am, the same thing, same calculations have to be performed there.
All the informations are given. Yeah, the same calculations has to be done here.
There is no additional thing which we have to perform this time.
No, this everything is same. You can look at the criterias and just like do everything, whatever is given there.
Actually, both the activities are matching week 5 and week 6. So I was confused between either we have to do the same thing again or something else. So I thought of clearing this doubt from you. Okay, thank you, ma'am.
Yeah. So here it is to approximate a variable with continuous random variable. Yes,
okay.
Given.
Ma'am, can we use the expected value also?
Yeah, if you want, you can do it.
Ma'am, to show the distribution, which distribution the following data follows, we can use this expected value of variance or these kind of things, because using this also we can find the distribution pattern.
Yeah, you can try to do it. Yeah, I mean,
but without getting the distribution, how can we get the expected value? Right. First, we have to decide which distribution is that.
No, actually, from distribution also we can prove this.
Okay.
Sorry, for expected value, we can prove the distribution, because there was one question, if you remember, it was like number of customers visiting follows a Poisson distribution or not at a particular shop. So from there only, we have used this expected value thing to find the distribution.
And then from the data in activity, how will we get the expected value?
Then we'll use data there.
Okay, directly from the Google Sheet. Okay.
Yeah, from the Google Sheet we can find out the probability and the proportion.
Yeah.
Okay.
Yeah. Thank you.
Okay. Thank you, ma'am.
Yeah. Anything else from week 1 to 5?
Ma'am, one thing I will request one session for this, the distribution finding and fitting into the curve based on the data in a collab sheet, because
yeah, okay, that is all.
Because detailed session has not been done, only lectures are there.
That part is also there in week 8 or week 9.
Okay.
Fitting the distribution with the data, it is there.
But ma'am, this activity is passing. We are not doing confidently. We are just copying, pasting, doing like that, and just getting the reviewed. but we should be confident that this what we are doing is modeled perfectly.
Yeah, so this part you will have to work a little on your own, because this is not this is just
No,
the
no,
bonus.
one session.
You'll have
What
to learn. Yeah, so
data is there. We are studying the.
Go till week 9. If it is not clear, we can have one session.
Okay.
So given
Ma'am,
the
one
data,
thing here. Yeah, ma'am, in these lectures which we have just read in the previous weeks, we are just getting the question, the problem sums, and we have to do all the probability calculation and expected value and following things, and then we'll able to find the things. But what about if the data is given the same as the collab notebook? The data is given, and then from the inference of the data, we have to include that this thing follows this thing goes on this. From data, how to perform the calculation, it becomes very difficult for because there is a large data. Are we going to study it in future upcoming weeks?
okay, so when you said you have the data and we are entering this, so like what did you mean when you said that?
Ma'am, I mean that if some particular question is given to us, that this interval is given, and you have to use this distribution, binomial or something, or exponential or uniform, and you have to find what is the probability lying between this region, what is the expected value, and what all the calculations regarding this probability and expected value from that very particular question. And but we don't know that how practically to do the statistics things when we are giving a particular data of some rows and some columns, and then how to perform the calculations in a practical way when data is given to us directly.
Yes, so when once you move to week 7 onwards, so you will study such kind of cases from in week 9 mostly. So given the data, how do you calculate various things? How do you fit a distribution?
The same thing I was asking you. I think it will be in the
Yeah, so
9.
once you move to statistics part, it will be things will be more clear how to use it. So until now we were studying just the probability calculation part. We haven't looked into any of the statistic part, but as you move to other weeks, you will come across the statistical things, like how to use it in real life.
Can we share infer from this? We studied this probability because this probability will be used for the modeling of the data in the next weeks.
Yeah, so
is it so?
Yeah, so in stats 1 you have seen descriptive statistics and inferential statistics. So now we are moving to the inferential statistics part.
Then it will be clear model, right?
Okay, any other question? So, okay, how was the exam? How was the quiz fun for all of you?
Not so good.
It was lengthy.
Not lengthy. My practice was less. I think comparatively we did not do the practice what was required. We can't say we don't understand the concept, but practice is required to do in time. This was the problem.
Okay.
I could solve the question, but after within that time we could not do that, because what we did we concentrated on the lectures. Lectures were total theoretical, and activity was good, but we could not do the activity. This is our drawback. So we did not do that properly.
No, ma'am. Actually, I did the activity question and all the practice in graded question, but then also I feel that paper was quite lengthy to cover it in 1 hour. So I have taken 1.5 hours for statistics, and then the remaining hour, that is the half an hour for Python. So it takes a lot of time during the quiz.
Okay, all right. Anybody else?
No, that I don't have the regret, because Srishti is so much interested about the activities I have seen across. So I think it was really lengthy, because I was feeling that my part was weak, so I could not say that. But we should do hard, no problem. I think we understand the concept. We have to practice. We need some time, ma'am. Nothing else. We'll do it. We'll do it.
Exactly what is happening, we are studying 2 or more than 2 courses at the same time, and we are getting the same 1 week time, and we have to we also have the pressure to submit the graded assignments and all these activities things, and also understanding the concepts again and again, so we can't get more enough time so that we can practice it as it is required in the particular course. So that's what happens with most of the people.
Absolutely agreed with Srishti, because this is the problem. We are doing but not getting the time proper, or the you can say some more span of time is required. Just in short word, we can say.
Okay, like once the result comes, we'll see.
Our standard is not
if something can be done
up to the mark.
No, it's something like
no
that. You can always learn.
There were no direct questions.
Yeah, what
all the question had.
There were
Mr.
direct.
Beoth, can we say something?
Yeah, please.
Yeah, please.
So there were no direct questions. And that is where each and every question perhaps had to be interlinked with multiple concepts in order to get it. And that was the reason, I mean, we found it lengthy, or the questions were not being able to solve. With 2 papers, again, both the papers were equally strong. The time wasn't sufficient to think about the concepts. The number of questions also that was written were large. So all were given together to solve, and hence perhaps the level of difficulty was quite high.
Okay. So
it was moderate to high, not definitely easy.
So
moderate
there
to
were
high.
You said there were no direct questions, but there were few questions that were very direct. I mean, you look at the question and you can directly say this is the answer, even though it was just for 1 or 2 marks, because there were few direct questions.
Yeah, I mean, yeah, there were few, but I wouldn't say no, but yeah, very few with the marks of 1 and 2. That definitely makes the paper a bit tough, right?
Okay, so what I wanted to say, like,
and there have been some papers, where there was a mix of direct application and 1 or 2 questions with multiple concepts getting included.
Okay. So yeah.
Probably it's difficult for the people who have taken 4 subjects together. If somebody has taken 2 subjects.
If that is the case, it's going to be really difficult.
Yeah. So if somebody has taken English with math or stat, Python with math or stat, it's balanced approach. Now, if you are taking all the 4 together, it's really a challenge.
Yeah. So how was the quiz for you?
I find it difficult. I've taken all the 4.
Okay. All right.
Yeah, I'm just putting the hand everywhere, but end up in knowing nothing. It's too demanding. 4 subjects, it's too demanding.
All right. So yeah, we have like taken into consideration all the feedbacks you have posted on Discourse. So we'll see, looking at the result, if something can be done in the next quiz.
Actually, in my previous term, I was also having the 4 subjects with me, but then only I was able to complete whole of the course for the particular week in 5 to 6 days, very easily. And but now there are only 2 subjects in this term, but still I was not able to complete it in 7 days. It takes me a lot of time because I need to.
Semester 1 was quite easy. Like,
yes, ma'am, that was easy.
But this semester 2, you have maths 2. That is also you're studying very advanced stuffs in maths 2. Even stats is not very easy right now.
Stats part is probably very difficult from stats 1, but it was not with maths part. Maths second was difficult, but not this much difficult as we compare to the stats 2 thing.
Okay.
The order of difficulties comes with stat comes first, math second, And then Python and English is just okay.
Okay.
And Nikita, another thing, the questions around steps, that was something operational challenge that I want to highlight. We read the question and then we used to swipe back and forth in terms of the steps and the questions. So it was not kind of very convenient to
Yeah,
find the steps and then write.
yeah, that also we have, yeah, like we
Yeah.
have talked about, and from next time we'll try to do something.
In the formula listing, and we saw a set of formulas with the numbers. Below that, there was a couple of tables. There is no number, but we did use those tables in solving the questions. So we were not able to really connect that one in your steps.
Okay, so the idea was, so there was a formula file that had been shared to you on the portal before the exam. So
Yeah, the formula file has serially
so that,
numbered part, and below that there are two tables. There is no line number.
yeah, so below that there was one more table that was list of options. So there what you had to do is, like, there were 5 questions for which you had to put the steps. Like if you're solving a particular question, let's say you're solving question number 1, and whatever steps you have used to solve that problem, you had to look at the steps in those list of options or the formula that you will use, and you just had to mark it. I mean, you just had to write the option number, right? So if you do that also, in case let's say your first question, whatever the question was, you got it, you got the calculation wrong and you got 0 marks for that. So what you can, like, if you have solved, if you have tried the other question and if you have written the steps correctly, so you can get some partial mark for that particular question. So that was the idea for this type of question.
Ma'am, one request from my side. Ma'am, we as the difficulty level cannot be decreased from for stats 2. So if the number of questions can be decreased, so it will be very helpful for us to deal in quizzes.
Yeah, we'll see what can, looking at the result for this time, we'll see how to go about it.
Because previously in stats, when it was, the concepts were easy, as calculation takes a long time. So this can be solved using the calculator thing. We can somehow manage it, but here we have to use some concepts and we have to think what can be used. This thinking part takes much more time than the calculation part in
Yeah,
stats
the
2.
calculation part, yeah, in stats too, there is not much calculation. Like if you look at the question paper in exams, the calculation is very less.
Yes,
But
ma'am.
just you should get the idea and do it correctly.
Yeah, do it correctly, and this thing probably takes much more time, because calculation is not the issue here, but understanding the thing and just striking the concepts into our mind takes much more time here. So if we can reduce the if you can reduce the number of questions in this very particular course for stats 2 for the quizzes, then it will be helpful for us to deal with it.
Yeah, like I have noted it down and we'll see. Okay.
Yeah, okay, ma'am. Thank you.
Yeah. So nobody has any doubt from week 1 to 5. Is it all fine?
As somebody was telling in the comment section that flipping back and forth to map out the steps.
Yeah, I saw that.
It's better to give the formula sheet as a separate sheet. Like in the for semester 1, all the T charts and the normal distribution charts are given and they collected it back. If
yeah,
people
so
can give it a separate sheet.
Yeah, this time also something can be done. Like for the second quiz. Yeah.
Right, that would be a good thing. Thank you.
Yeah.
Hello.
Yes.
Yeah, I just have to add something into that exam feedback. That is what I just thought of. Like, someone was telling like to reduce the number of questions or this thing. My suggestion is actually you used to take that with the solve with the instructor kind of lessons where one problem used to get split it into multiple this thing and into step by step mode, like prelude to one, prelude to like that. So if the exam also, like, rather than reducing the questions, it can be like, if there is a complex question, you can move into, let's say there are 3-4 steps are there will be interim results for all those things, right? So so those interim results, if we split it into, say, 3 questions, and the final that last question be the final result or something like that, that will make us to score better actually, because at least we'll have like 1, 2, 3 like that, it will go on. Okay.
Yeah.
So
Yeah, right now also, like if you look at the quiz paper, like there are few questions where you have to use a particular like a set of information, and then you have to solve some few set of questions. Like
issue here is like, no, issue here is like you are for a particular question, you are always asking for the end result, and you are asking for the step into the next question, like 1, 2, 3 or 1, 4, 8, like whatever formulas we have used, like that, right?
Yeah.
So rather than that, if we can really split the question itself into three or 4 parts and allocate individual marks to those questions. Like if it is a, say, 5-mark question, say step 1 will have, say, 1 mark, step 2 will have, say, 2 marks, and step 3 will have, say, balance 2 marks, something like that. If it goes on, no? Then that is easier to follow mentally.
Yeah, that is what I'm saying, that right now also we have this concept in the quiz paper, but it is not so like a lot. Like for the NET type of question, they had given the word cloud type questions where you had to select a list of options, and there were few questions where we had split the question in steps, like this for if this is a particular question, these are the steps we are going to use, and if
That
it's
happens,
solved,
but normally it is a bit difficult to form such questions also, that I understand. Like what happened into my previous term, Maths 2 was like Maths 2, the entire, they had some, out of total 12 or 13 questions, I remember 7 or 8 was like this, based on one single concept. And all those 8 questions were of the 9, 10, and 11 week, which I did not focus much. So that was where I end up in trouble actually. So it is a bit difficult to form such questions on a. I understand, but that if it can be done, that is better.
Okay, all right. Okay, anything else?
I think we can call it a day.
Sorry.
I think I said no. I think we can call it as a day.
Okay. All right. So you all can start going through week 7 content if you haven't started. I hope you will like the statistics part. I hope you enjoy this statistics part more. So yeah, if you have no other doubts, should we close the session now?
Ma'am, one thing I want to ask here. Ma'am, in the next session in Solve with Us, which weeks are we covering?
Week 7, right?
No, ma'am, it is Solve with Us for week 6.
No, there is no solve with this for week 6. Can you check the calendar once?
Ma'am, maybe I have not seen it properly.
Yeah, so today it was an open session for week 5 and 6. And since there was no graded assignment, so there's no solve with us. And this Friday is going to be the session for week 7. Then you have a session on Monday and then one on the next Tuesday, or solve with us for week 7.
Yes, ma'am. Yes, ma'am. I've not seen it clearly. So it's week 7.
Yeah, right.
Okay. Thank you, ma'am.
Yeah, thank you.
Thank you,
The
ma'am.
session on Monday, that's an open session or specifically related with the week 7? Because in the calendar it says open session, just like today.
Open session for week 7, for that particular week.
Okay, it does not say that. It just says open session stats 2. That is why I was asking.
Okay, so okay,
It
we'll
just reads
mention
open
week 7.
session, same
Okay.
as today. That
Okay,
fine.
okay. Yeah, we'll update it.
But it is specific for week 7, right?
Specific for week 7. Yeah.
Okay, fine. Thank you. Thank you, Nikita, for your time.
Yeah,
Thanks.
yeah. Thanks.
Thank you, ma'am.
Yeah, thank you. So you all can drop off now. Karthik, please close the session.
Okay, ma'am. Thank you, ma'am.
Yeah, thank you.